Hey there, it's Mr. McTavish here, and we are going to go over some features of FTCSim. So, when you get to FTCSim, if you scroll down the screen, you'll find these links. The FTC intro is where we're going to be starting. You want to make sure that you do log in to be able to save your progress, and you won't be able to access the movement and the sensors and the puzzles until you have done that. So make sure to log in so that you can save your progress. I'll have details about logging in Google Classroom. So the goal is to work through all of these challenges and try to get as many done as possible. And obviously, the earlier challenges are a little bit easier, and the farther you go, the more challenging they are. But a couple things when you are in the first challenges, you will notice that there is a guide. You've got Lisa and Dozer, and there is the continue link. That continue link is going to be really useful. They walk you through all the directions, and so pay attention to it. If you accidentally close that, then you can click on that help icon, and that will allow you to open up the guide again, and you can work through it. So use the guide. They give you tips, and that will be really informative. When you're thinking of the robot, this is kind of the basic configuration. This is called a tank drive. You have a motor on the right and you have a motor on the left. And when you're referring to them in code, that's how they're written. So the motor on the right will obviously turn this wheel, and the motor on the left will turn the back left wheel, and the ones on the front are just freewheeling. So when the motor on the right, when power of 1 is applied, that's the same as 100%. So that will turn the wheel clockwise, and so that will result in the robot, the wheel moving forward in that direction. Now, keep in mind, you can use any decimal numbers. So a 1 is the highest number, that's 100%, so full power. 0 is no power at all, and -1 is full power but in the opposite direction. So you can control your speed. You could set 0.5, for example, to be able to go at 50% power, or -0.5 to go 50% power the opposite direction. Now, when you're thinking of this, the right motor, the left motor is actually flipped. So 100% power on the left motor actually turns it the opposite direction. So in your first challenge, that's one of the first directions, is just to try to go 100% on both. And what will happen is that the robot will pivot because you've got the right wheel going forward, the left wheel going backwards, and so the entire robot will turn. Being able to turn the robot is a really useful skill, but to be able to go in a straight line, we have a couple of strategies. The key strategy is setting it so that our motor left direction is inverse. And basically, that means that if we apply 100% power, this direction will actually reverse it. And because the motor is flipped, that means that it will go in the direction we want it to go. So being able to find the correct commands over on the left is really important. These blocks, it's very similar to using Scratch. You have your categories and then your individual blocks that you use. Those of you that are interested in programming, you can actually see what the Java programming for this, so that can be really useful. And we also have these dual blocks, so they control the left and right motors together. So if you've added that reverse, then this will allow you to have your robot go forward at 100% speed. I'm also pointing out this command here, which is the exact same command, but the speeds have been set to 0. This is useful when you want your robot to be able to stop. Now, when you have completed a field, before you go on, make sure to take a screenshot. So a screenshot on Windows computers, Windows, Shift, and S. So there are the three keys that you need to hold down. When you do them, that will freeze the screen and you'll be able to take a screenshot, and that screenshot you can then paste using Control V into your document. So every time you finish a program, take a screenshot of the blocks and paste that into your documentation so we can track your progress. On the Chromebook, it's the same thing. You've got your control button. Whoops. You've got your control button here, and up here it's the Windows button. So actually on the Chromebook, you should be able to hold Shift down as well to be able to take a screenshot on your Chromebook. So you have that sheet, and the goal on your sheet is to track every project that you do and so you check off that you've done it and you take a screenshot of your code to show what you've done. Now, the first program or two hopefully won't be too hard for you, but as you progress, the challenges do get harder, and there's a couple key things to keep in mind. Number one, take your big problem and break it into smaller problems. So when you get to this particular problem, it's a little bit challenging, but the key thing is it's actually based on previous programs. So if you've been keeping track of your screenshots, then you can go back to them and, oh, that's how I did that. So you can use that code. And the biggest thing is break your problems into small problems. So in this thing, obviously you want your robot to get to the flag, but the first thing you have to do is be able to turn the robot. So if you just focus on turning it, that makes it a lot more manageable. Now, with a lot of this, there's some other strategies. One of them is called methodical guess and check. And the idea here is that we know we want to turn. Well, when we've set the reverse motor, if we set our power to 1 and -1, that will turn the motor. So if we look at this way, we want the robot to turn this direction, the direction of the arrow. So that means the left motor should go forward and the right motor should go in reverse. So that's what I've set here. We've used the simulator sleep for 1,000 milliseconds. So basically we're going to wait 1 second and then we're going to turn the motors off. So what we should see is we should see the turn. That turn will happen for 1 second and then the robot will stop. And because we're not in the loop, it will just run those 3 things and then whatever's in the loop, at which we don't have any code at the moment. So when we do this, we found that the robot turned all the way around. So 1 millisecond is all the way. 500, it looks like it's a little bit more than that. So 500 is probably too much. So this is the methodical guess and check. So instead of trying 500, we're going to try 400, and that should turn us right where we want it. The other thing is to look for patterns. So in this example, the moment we've got it turned, now we have a pattern here, which we actually would have solved in one of the previous programs. But the pattern is go forward, turn, go forward, turn, go forward, turn. So we can use that loop block instead of adding all these blocks, and we can just go repeat, forward, turn. So some common blocks that we've used in that, the simulator sleep, so that's in linear op mode. So that allows you to add a pause, and that's really handy. So turn your motors on, wait for a second, turn your motors off, and look at look at where the robot is, and then make a decision about how many milliseconds that needs to happen to be able to go where you want to go. The other one is setting the motor left direction to reverse right at the beginning of the program. So that's done. We shouldn't need to do it after that, but that allows us to always kind of go if our motor left and motor right are 1, the robot goes forward. If the motor left is 1, motor right's -1, then the robot will use the left motor will go forward, so we'll be actually turning to the right. And if we flip that, then we're turning to the left. And if they're both -1, then you go backwards. And being able to set the power to your different speeds and set your motors to 0 so that you stop them. And that's it. Good luck with it. Keep track of your progress, and I look forward to seeing what you get done in the next day or two.